Okay, let me start this video by um, continuing with the sections under Chapter 2. Last time we did up to um, section before complex numbers, so I'm going to start with basics of complex numbers and continue from there. Now, before I do that, let me turn off the video. We don't need that. And then continue with complex numbers. So now, where do they come from? They have a history, of course, and I'm going to talk about a little bit about where they come from. There was a mathematician called Cardon, and he was thinking about the problem that if you have a, let's say, a rod, and you want to divide, there's 10 units, and you want to divide it into two parts such that if you multiply x times y, you get 40. And we know since the whole thing is 10, then x plus y equals to 10. So basically we have two numbers that they add to 10, but then they multiply, you get 40. Now he realized that there are no real numbers that actually satisfy this equation. So he did it this way. So he said, okay, let one number be x, the other number would be 10 minus x, right? Because the whole rod is 10 and as part of it is x, then the other part would be 10 minus x, because this whole thing is 10. So, and then he says, okay, I'm going to multiply these two numbers and set it equal to 40, as you see right here. Now, when you try to solve that problem, and of course he did, and he got a quadratic equation, and when he tried to solve it, he ended up with using quadratic formula, which we're going to talk about in a few minutes. But for now, he used the quadratic formula, and he ended up with this expression for the two solutions. Now there's a problem here, of course, and you see the problem is that there is a square root of a negative number there, which doesn't make sense. So in his time in like 1500s, they basically ignored this kind of equations and they didn't have any solutions for them. They didn't need any solutions because the solutions were not real numbers. So they called them impossible equations. But he was one of the first that says, no, why don't we just add these two numbers? Well, obviously, if you add them, you see that these two, whatever they are, they don't make any sense because the square root of a negative number doesn't make sense. He said, whatever they mean, well, we just subtract, since they're opposites, we can cancel them, we get 10. So it does work. They add up to 10. Now, is the product 40? And he said, basically, this is how he put it, putting aside the mental tortures involved, multiply to get 40. Now, by mental tortures, of course, he meant that it doesn't make sense to multiply these. But he did them. How did he do it? Well, this is how he did it. Basically, multiply. These are difference of two squares. So it's like a plus b times a minus b. So the answer is a squared minus b squared. So this is a squared and this is b squared. And he said, okay, a squared is 25. Now, what if we say that the square root of, when you square this, the negative 15 comes out, we just get negative 15. So 25 minus negative 15 is 40. So that is actually correct. So he said, why don't we just use these numbers? Maybe they're good for something. And that was the first time that complex numbers actually came to exist. Now, how do we deal with them? Well, complex numbers are basically this number right here, I, is the unit that we call imaginary unit. And that is the square root of negative 1. So if we have a negative number under a square root, that's how we deal with it. We consider it to be negative 1. So we consider it to be a square root of negative 1. I is the square root of negative 1. So if I want to multiply this number by this number, I'm going to first convert it to I form. How do we convert it to I form? Well, the square root of negative 21 is basically square root of negative 1 times the square root of 21. And this part right here, we're going to assume that that is I. Now, with the definition of complex numbers, I squared is negative 1. It's defined to be negative 1. So I is defined to be that, and I squared is defined to be negative 1. So if we write the square root of negative 21 as I times square root of 21, and I times square root of 21, the answer would be I squared. I times I is I squared, and square root of 21 times square root of 21 is just 21. Now, I squared, as I said, by definition is negative 1. So we get negative 1 times 21, which is negative 21. That's how we simplify it. That's how we make sense of a complex number. Here's another example. Again, negative 5 under radical doesn't make sense. So we can write it as I square root of 5. And this doesn't make sense. So we write it as I square root of 30. And when you multiply, we get basically square root of 150. And 150 can be written as 25 times 6. And 25 comes out as 5. And I squared is negative 1 again. So that's negative 1. And then that's just 5 square root of 6 times negative 1. That's negative 5 square root of 6. Okay? Now, how do we divide these numbers? Well, the same way. First, we write them in terms of I, and then we divide them. So square root of negative 42 is I square root of 42. And square root of negative 3 is I square root of 3. So that's how we deal with it. And the i's go away. So we just get square root of 42 over 3, and that's square root of 14. All right. Now, here's another one. We have a square root of negative 63 over square root of 21. Now that is written this way, but the square root of 21 is square root of 21. So we keep the I, and we put these under one radical. And 63 over 21 is 3. So this is I square root of 3. All right. So it says, write a complex number is a number of the form a plus b, bi, where a and b are real numbers and I is the imaginary unit. So gradually, when coordinate plane were invented, people started doing geometry with complex numbers. So they say, okay, they created a two-dimensional complex plane where the horizontal is real and the vertical axis is an imaginary axis. So they said, let's consider numbers to be to have two parts, the real part and an imaginary part. The imaginary part is the coefficient of I. So for example, this number right here this is 3, this is 2, and this is imaginary axis, so that's actually 2i. So this is 3 plus 2i. So every number in the complex plane can be represented by a form a plus bi. So, and that is called the standard form. So we have a real number plus or minus a real number times I. So we can write complex numbers in this form, and now we have some kind of a geometric representation of complex numbers. All right, so here, this number has a denominator, so this denominator is a common denominator, so we can separate it into two parts. We can think of this as 15 over 5 minus square root of 75 over 5i. Now 15 over 5 is 3. Square root of 75 divided by 5. Well, we can write the square root of 75, we can write the square root of 75 as 25 times 3. So square root of 25 can be written, 75, can be written as 25 times 3, like that. And then 5 comes out, so that's 5 is square root of 3. So it would be 15 over 5, which is of course 3, minus 5 square root of 3 over 5i. They get canceled to be 3. So we get 3 minus I is square root of 3. That's how we write it in the standard notation. So how do we add complex numbers? Well, it turns out that adding complex numbers this way is pretty useful. For example, let's say your boat wants to go this way, and this is, let's say, well, my drawing is not very good. So let's say that you want to go this way, and this is 4, and this is 5. So your boat wants to go that way, right? You want to go that way with your boat, and you want to go with this velocity. The length from here to here is the velocity, and the direction of it is given by that direction. So this is, think of it as a 5i, and then let's say the wind is blowing in the direction of -5 and 8. So -5 is this way, and 8 is this way. So -5, 8 is kind of like that. So let's say this is -5, and this is 8i. Okay, now, if you want to go that way with your boat, with that velocity, and the wind is blowing this way, in that direction with that velocity, which direction are you going to go? Well, it turns out that the direction that your boat is going to go is actually the sum of the two. Now, what do you mean by the sum? We mean basically add them. So we add the real parts, and then we add the imaginary parts with the I. So basically think of I like an x. So if you were to add 4 minus 5x plus -5 plus 8x, just put the real parts together, put the x parts together, and add them. So we get -1,3i. Now -1,3i would be kind of like this point right there. So basically your boat is going to go that way, even though you're trying to go that way with that velocity. But because of the wind, your boat is going to go this way and with this velocity, which is the length of this vector. It's called in physics. So they have many, many applications, these complex numbers. In algebra, we are just interested in representing the solutions for equations that I just talked about, right? The original idea that Cardon had. If you have something that is 10 units and you want to divide it into 2 parts such that the product of the parts is 40, that problem. All right, so to add is easy. You just add the real parts. So -6 plus 12 is +6. -3i minus 9i is minus 6i. All right, how do we subtract? Well, to subtract complex numbers, you have to distribute the minus and then just add, right? Just add the parts. So all we have to do is distribute this minus, and then you can remove the parentheses. That's and then just put the real parts together and put the I parts together, and you're done. All right, here's another one. As you see, 15, this is going to be 15 minus 8i plus 10 minus 4i. Now these, don't forget the signs, right? They're both positive, so that's 25. This is negative, so that's minus 12i. All right, Now, how do we multiply two complex numbers? Well, if we know what I squared is, then we shouldn't have problem multiplying two complex numbers. So I squared is -1. So we multiply, think of I as x. If it was x, you would just do the distributive property and then combine all the like terms, right? And we end up with this right here. So we get 10 minus 35i plus 6i minus 21i squared. Now, what do we do with that I squared here? Well, we're going to represent that as -1. So that's -1. So if that's -1, this is just -21 times -1, because that's a multiplication here, right? Which is positive 21. So this would be plus 21, right? And the 21 plus this positive 10 is 31. So 31 minus 29i. That's how we multiply two complex numbers. How do we raise a complex number to the second power? Well, it's the same thing. It's like multiplying that by itself. But we know the identity a plus b squared. Remember? That identity is a squared plus 2ab plus b squared. That's the idea. So basically it's 4 squared minus 2 times 4 times 5i. Right? You can think of this as a, think of this as b. So it would be minus 2ab plus b squared. Again, what do we do with that? That's -1. So this right here would be -25. Now 16 minus 25 is -9. So the answer is -9 minus 40i. All right. Now, if you want to multiply more than two complex numbers, then we're going to have to know what are the powers of I. Well, it turns out that I to the first power is just 1. I to the first power is just I. I to the second, we know by definition, is -1. But what about I to the third power? Well, we can think of I to the third power as I times I to the second power, right? Because when you multiply these two, you have to add the exponents and you get the same thing. But we know what I squared is -1. So I to the third power is I times what? Times -1, which is -i. So I to the third power is -1. And then if you do I to the fourth power, now you can think of I to the fourth power as I to the second power to the second power, right? This way you multiply the exponents, right? Now we know I to the second power. What is that? Well, that's just -1, right? So that would be just -1 squared, which is 1. So if I write I to the fourth power here, looks like we go back to number 1, right? And then if I do I to the fifth power, I get this one. And I to the sixth power, I get the next one. So it looks like that it's there's a pattern involved. And that pattern is this idea. If you start from I, which is right here, right? In the complex plane, this is I by itself. See, a complex number is a plus bi. So if I only have like I, that means a is 0 and b is 1. So that ends up being over here, right? Now, if you start with that, notice that if we keep multiplying by I, so if I start with I, if I multiply by I get I squared, which is -1. And then if I multiply by I again, I get -I. If I multiply by I again, so -I times -I times I is -I times I is going to be -I squared, which is, this is I squared. So this is -I And then if I multiply it by I, it would be negative I squared. My pen is not working properly. Let me fix that. So it would be, if I start with negative I and multiply it by, get my pen working here. So negative I, and if I multiply it by I get negative I squared. But we know I squared is negative 1. Negative 1 is going to be positive 1. So we end up over here. And then if we multiply by I again, you go in a circle. So that means there is a pattern. So we only get those 4 numbers. When we raise an I to a power, we only get those numbers. And to get what number we get, which one of these 4 we get, well, it's really easy trick we can use. So let me get rid of all that. So what we can do is we can write, for example, I to the 33rd power. We can write it as so let's say, for example, I'm going to do an example before I do this one. What is I to the, let's say, 34th power? Well, I to the 34th power is basically I to the 2nd power and then to 17th power, because 2 times 17 is 34. Now, we know what I to the 2nd is negative 1. So basically that means that this would be negative 1 to 17th power. Now, negative 1 to the 17th power is negative 1. So the answer is negative 1. Now, what about I to the 33rd power? Well, I to the 33rd power, well, it's not divisible by 2, so I can't do this to it, but I can write it as I times I to 32, right? Because this has a 1, so that would be 33. And I'm going to keep the I, and then make I to the 32nd as I to the 2nd to the 16th. And that would be, well, let me do it here. That would be I, and then I to the 2nd is negative 1 to the 16th. That is going to be, well, negative 1 to 16 is 1. 1 times I is just I. Right? All right, so that's that we get I. So we get one of those 4 numbers, wherever we have one of these powers, we're going to get one of those numbers, right? In this case, for I to the 33rd, we get I, and for I to negative 14, well, since it's a negative here, we know that if you have a negative power, remember, what do? We'll move it to the denominator and make it positive. We can do that, right? So, now, so what we can do is this. This is a little bit more complicated than we need. Why don't we do it this way? We just write it as 1 over I to 14, right? Okay, now 1 over I to 14. Let me get rid of that. So if I write it as 1 over I to the 14th power, that would be 1 over I to the 2nd, right, to the power of 7, right, in the denominator. Now we know I to the 2nd is what? Is negative 1. So that's negative 1 to the 7th power in the denominator, and that would be 1 over negative 1, which is negative 1. Okay? All right. Now, how do we divide two complex numbers? Well, we can't. So we cannot divide by complex numbers, but we can use this trick. If we have a complex number like this and a complex number like this, if we multiply these two, we end up with a squared minus bi squared, right? Now, that would be a squared minus b squared and then I squared. But we know I squared is negative 1, so that would make this negative b squared positive b squared, like that. So that means now these two complex numbers are called conjugates. Now, complex conjugates are two complex numbers like these two. For example, if I have 3 plus I, its conjugate would be 3 minus I. And if we multiply by the conjugate of the denominator over conjugate of the denominator, that means as 1, this is 1. It doesn't change the value of this, but it gets rid of the denominator, and we have an answer. So here we go. So the numerator, we just have to multiply. 5 times 3, 5 times negative I, negative 5i times 3, negative 5i times minus I. That's what we get in the numerator when we multiply. In the denominator, we're going to get 9 minus I squared, which is actually 9 plus 1, that would be 10, because I squared is negative 1. That would be 10. So the shortcut is that whenever you multiply a plus bi times a minus bi, you get a squared plus b squared. Okay, that's the shortcut. So we could just go from here to from the denominator. We could go from here to there, because 3 squared is 9, 1 squared is 1, 1 plus 9 is 10. But the numerator we have to simplify, and we know how to simplify this because we know I squared is negative 1, and numerator becomes that, and eventually we get 10 minus 20 I over 10. This 10 belongs to both, so if we separate it into two fractions, we get 10 over 10, right, minus 20 over 10 I. 20 over 10, this is a 10. I put 110. There we go. And 20 over 10 is 2. Okay? So that's the answer. All right, now, of course, we have a calculator, but we don't use really calculator to do this. But if you were to use calculators, then you would have to you have to go to mode. You see over here it says complex numbers right there. If you change the mode to complex numbers, then you can add complex numbers. Now, there is an I somewhere over here for complex numbers. So let's say we got 5 minus 5i. Where is the I? But there is an I somewhere. Well, it's right here actually. Oops. Let me go back here and delete it. So let's see. No, that's not I. It's I. Here we go. Is that I? Is that I? I don't think so. There is an I somewhere on the calculator. Where is it? Oh, it's blue. There we go. Okay, there we go. So that is right here, is in blue. So we get that, and then divided by 3 plus I is right there. The answer is 1 minus 2I, which is the answer right here that we got, right? So calculators can work with complex numbers as well. All right, write in a standard form. Again, we have 15 divided by negative I. Now, what is the complex conjugate of negative I? Well, complex conjugate of negative I is just I. So here, we just have to multiply by I. So here, where did it go? Here, you just have to multiply by I, because I is the conjugate of negative I, right? So you see, A plus BI, the conjugate of it is A minus BI. Now, if you have a number, let's say 2 plus 3I, its conjugate is 2 minus 3I. But what's the conjugate of 2I? Well, we can think of 2I as 0 plus 2I. So its conjugate is 0 minus 2I. So conjugate of 2I is negative 2I. Okay? So that's the idea. All right, so let's continue, and we want to get the pen. There we go. So when we multiply, I times I is I squared, so that's negative I squared. I squared is negative 1, so negative 1 is 1. And the numerator is 15I, so that's 15I. Or in a standard form, that's what we write. So 15 divided by negative I is 15I. And that's how you get with the calculator if you do it. Okay, so let me go to Newton Alta and do some of the problems from there, right? All right, so basic of complex numbers. I'm going to do a few problems here. Let's see. So it says simplify I to 62. Well, I to 62, we could do this together and then. So what is I to 62? Well, I to 62 is going to be I to 2 to the power of 31, because 31 times 2 is 62. And what is I? I is negative 1 to 31. Now, negative 1 to 31 is negative 1, right? Negative to an odd power is negative, and negative to an even power is positive. So the answer is negative 1. All right, so these are basics of complex numbers, and you can easily, what is I to 63? Well, you cannot do it the way I just did it, so this one has to be done this way. So now we have to write I to the 63 as I times I to 62. So now we're going to keep the I, and then I to 62, we're going to write it like I to second and then to 31. Now we know I to the second is negative 1, and this would be I. Now what's negative 1 to the 31st power is negative 1, and negative 1 times I is negative I. So the answer is negative I in this one. All right, so this is basic of complex numbers. It says express the following in simplest form in terms of I. Well, in simplest form means you bring the negative out as I and simplify square root of 90. Now, square root of 90, what does it have in it? Well, square root of 90 is 9 times 10. So 9 comes out as 3, and then negative comes out as I, so we get 3i square root of 10. right? So let me also quickly do this. So we have square root of negative 90 is I square root of 90, which is I square root of 10 times 9, and that's 3I square root of 10, right? 9 comes out as 3. All right. All right, so let's go to another section, operations with complex numbers, right here. So it says divide the complex numbers. Well, we know that we can divide. So what do? We are going to multiply it by the conjugate, which is 4 plus 3i, right? And then 4 plus 3i. Now we have to multiply the denominator by the shortcut. The denominator is 4 squared plus 3 squared, which is 25, right? 4 squared is 16, plus 3 squared is 9, so that's 25. Now numerator we have to multiply. 4 times 41 is 164, plus 3i times 41 is 123i, and 4 times 13i is 52 is 52i, and then 3i times 13i is 39 i squared. That's the numerator. That's simplified. Now if you simplify that, 164, this is actually negative 39, right? Because I squared is negative 1. That makes it negative 39. 164 minus 39 is how much? It's 125, right? So that's 125, and these two add up to 173, right? So it would be 125 plus 175 I over 25. Now 125 divided by 25, we can separate them, right? And write it as 125 over 25 is 5, and 175 over 25 is going to be 7, right? So the answer is 5 plus 7i. That's the answer. And you see it here. All right, how do we add complex numbers? Well, we did a bunch of examples. We just look at it and see how we get negative 3 here. Well, because negative 9 plus 6 is negative 3. How do we get positive I here? Because plus I plus negative 7i is positive 1i. And that's how we get it. All right. Now here we have to subtract. So we have to first multiply by that negative, right? So in this case, let's do one subtraction as well before we move on. So we have negative 1 minus 2i minus 3 minus 7i. You have to distribute this minus. Now that's a negative 4. That makes negative 4 here. And these two make negative 9i. So that's the answer. Negative 4 minus 9i. All right, so these are operations with complex numbers, and I think you can get this under control. So I'm going to move on to solving quadratic equation equations by factoring. Let's see. All right, well, it says solve the following quadratic equation by factoring. Select all correct answers. Now, to solve a quadratic equation, we know we have to be able to factor it into, let me get some space here. All right, so what we have to be able to do is we have to be able to factor it so we can solve it. Why? Because then we can say this equals to 0 or this equals to 0. But what are the two factors of this? Well, to factor, there's a procedure. You probably learned it in other courses. This number right here, if it's not 1, you have to multiply it by this number. So that's 12. Then we're going to find two numbers that you multiply, you get 12, and you add, you get negative 13. What are two numbers you multiply, you get 12? No, we start with 1 and 12, of course. And then what about, is 12 divisible by 2? Yes, 2 times 6. Is it divisible by 3? Yes, 3 times 4, right? And is it divisible by 4? Yes, but you get the same thing. So we stop right here. Is there 1 times 12 or 2 times 6 or 3 times 4? That's the ways you can get 12. Now, we want the one that gives us negative 13. Well, we can't have positive numbers give us negative. So that means these have to be negative. Now, when you multiply two negative numbers, you get positive number. So this one looks like if you multiply, you get 12, you add, you get negative 13. So the numbers that we need are negative 1 and negative 12. So let's erase the rest of this. We don't need it. All right, now how do we factor this? Well, to factor it, we're going to break the middle term into two terms with these two numbers. So 2, we're going to write it as 2x squared minus 1x minus 12x plus 6 equals to 0. So you see, we just we wrote the middle term into two terms. Now these two, we can do factoring by grouping. You can take these two and these two. What do they have in common? Looks like what they have in common is just x. So if I take x out of 2x squared, I get 2x. And if I take x out of x, it's just 1, right? And you can check, multiply, and see if you get the same thing. And then here, we could take minus 6 out of these two, right? If I take minus 6 out, if I take minus 6 out of minus 12x, what do I get? Well, we have to divide. Minus 12x divided by minus 6x, which is 2x, right? Minus 6, not minus 6x. Let me erase that, okay? So that's 2x. Now, what do we get if you take minus 6 out of positive 6? Well, let's see, 6 divided by minus 6 is going to be negative 1. And when you multiply, you say you get the same thing. But the good thing is that now we can actually think of these two, see what do they have in common. Now what they have in common is 2x minus 1. And if you take 2x minus 1 out of this, you get x. You take 2x minus 1 out of that, you get minus 6. So the two factors are those two, right? So now we can just say, okay, in order for this times that to be 0, either 2x minus 1 is 0 or x minus 6 is 0. So from here, x is 1/2, and from here, x is 6. All right, so the answers are those two. So the answers are 6 and 1/2, as you see right there. Okay, so that's quadratic equations by factoring. And here is here's another one. Again, the same thing. 5 times -9 is -45. So we want two numbers, you multiply, get -45, and we add to get -4. What are the two numbers? Well, let's do one more of these. Well, the two numbers will be, let's see, so -45. Well, 1 and 45, right, is not divisible by 2, but it could be 3 and 15, right? It's not divisible by 4, but it could be 5 and 9, right? Now, remember, we want negative. It has to be -45. Either the 1 has to be negative or 45 has to be negative. Now, let's say the first one is negative. And that's all really we need, because if you continue, you get to 9, and then 9 times 5 is the same as 5 times 9. So either we have those, or we have the ones that these are positive and these are negative. So which pair should we pick so we can get -4 when we add them? Well, it looks like that one. So the numbers that we need are 5 and -9. Okay, so if we have 5 and -9, then that means the middle term has to be turned into plus 5x minus 9x minus 9 equals to 0. And then we take these together. We have 5x in common here. So this would be x plus 1. And they have minus 9 in common. That also would be x plus 1. And they have x plus 1 in common. And now we could say that either x plus 1 equals to 0, or 5x minus 9 equals to 0. And x plus 1 equals to 0 gives us -1, and 5x minus 9 equals to 0 gives us 9/5, right? And this one, of course, gives us x equals to -1. So the answers are 9/5 and -1. All right, so that's how you do it by factoring. If this number is 1, then it's even easier, because 1 times this number would be a smaller number. And in fact, you don't have to break the middle term into two terms anymore. You can just directly do it. So let's do another one of these. It's like, okay, now in this case, for example, that's 1, so that's easy to do. So all we have to do is let's see. So all we have to do is do, let me turn some of my programs, close them. The computer is a little slow. Okay, so we get -16, so we need two numbers. You multiply, you get -16. You add, you get +6. So 1 and 16, 2 and 8, and 4 and 4, right? And that's it. Now we have to get negative, so either these are negatives, or 16 is negative, and 8 is negative, and 4 is negative. Now, which pair gives us +6? Well, it looks like this pair right here, right? So the numbers that we need are -2 and 8, and you don't have to break the middle term anymore. You just have to write, if the coefficient of a t x squared is 1, the answer is just t t, and put those numbers in the parentheses, -2 plus 8. And that's it. Those are our factors. Now, if the coefficient is not 1, then you would have to break the middle term into 2 and then do factoring by grouping. So either t equals to 2 or t equals to -8. All right, so we got two answers, and then you have to put them in and with the separate them by a comma. -8, 2. All right, so that's how we do these problems. Let me move on. Completing the square, let's talk about that quickly. So solve the following equation for x. Now here, what is completing the square? Let's talk about that for a second, and then we continue. Now, what is completing the square? Well, completing the square comes from this idea. If we have x plus b squared, that would be x squared plus 2bx plus b squared. This is an identity that is very famous. Now, so if we have something on the right, let's say x squared plus 6x. Now, what should I add here so I can write this as something is squared? That's called completing the square. So basically completing, because this is not complete, something is missing here. If we have a number here, then we would be able to write it like this. Now, what is that number? Well, it looks like this number is b squared, right? This number is b squared. So all we have to do is find out what b is, and b is always half of that number, right? So in our case, half of plus 6 is positive 3. So that's our b. And then b squared has to be 9. So if I put a 9 here, then I can write this as x plus 3 to the second power, right? This is also true if it was a minus. So if I have a minus here, right? If I have a minus here, this would still work, right? So all you have to do is, let me make this minus, and I want to make this minus too. So what if we had a minus 6x? Then our b would be -3, and b squared still would be 9. We still put plus 9 here, but then when we write this part, we write x minus 3 squared, right? Now that's the idea of completing the square. The reason we do that is because there are many examples where that factoring that we just did in the previous section wouldn't work. The numbers wouldn't be nice, so you would not be able to find two numbers, you multiply, you get something, and you add, you get something else. When that happens, when we use this completing the square. So it says solve the equation. Now to solve this equation, first of all, we can do this. This is easy to do because there is no x there, right? We can just isolate x squared and solve it. So we can just maybe we can move that. Well, let's do it this way. We can do minus 2x squared. We don't even have to do completing the square because the square is already complete here. That means we have something squared already. So we're going to move that 122 to the right side. And then what is 24 minus 122? That would be minus 98, right? 24 minus that would be, 98, minus 98. So that's negative 2x squared. So if you divide by negative 2, you get x squared equals to, what's half of 98? 49. So x is going to be, you take a square root of both sides, it would be plus and minus 7. So that's the answer. That one is easy because it's already in the form that we like it. So you write it as negative 7 comma 7. All right, so let's do one more. Solve m squared plus 8m equals to negative 3 by completing the square. Okay, now here we have an example where we all have to use that idea I just talked about. So let's do this. So here, m squared plus 8m. Now that number right here is not going to work for us. So I'm not going to even bring it to the left, because it would be hard to find two numbers, you multiply, you get negative 3, and you add, you get 8. So forget about that, right? So we're going to keep the negative 3 on that side. But think about how we can convert this to something squared, right? Well, that's easy. What's half of 8? Did you say 4? Okay. So half of 8 is 4. So that's our what? That's our b. And then b squared is what? What's b squared? If I can write on that, would be 16, right? So that's b squared right there, is 16. Okay, so I have to add 16 here. Now if I add 16 on the left side, I have to also add 16 on the right side. Now I'm able to write this as what? M plus, because this is a plus, basically half of that, which is 4, equals to, what's negative 3 plus 16? Positive 13, right? Now it's something I can solve. All I have to do is take square root of both sides. So what I get is I get m plus 4 equals to plus and minus square root of 13. So m is going to be plus and minus the square root of 13 minus 4, right? And that's what the answer is. There are two answers. We consider the plus first, so we get square root of 13 minus 4, and then minus the square root of 13 minus 4, the two numbers. Now, if you want to know what they are, you can put it in the calculator and get a decimal answer for those, but that's what they are, right? Negative 4 plus square root of 13, negative 4 minus square root of 13. Okay, so that's the idea of completing the square.